In this work, we aim to tackle a challenging yet unexplored problem. Our goal is to design a deep neural network capable of synthesizing realistic and controllable reactive motions in real time, conditioned on the observed input characters. The network begins by taking the observed motions as input and estimating the movement intention of the input character. This intention is represented as future trajectories of the character's joints. It is then encoded as latent vectors to align with the output features. Meanwhile, an output decoder learns to reconstruct the output pose from a quantized codebook vector. Since the intention feature is embedded with spatial relationship information between the two characters, it is difficult to capture using the codebook-based matching loss. We thus introduce adversarial training to improve the modeling performance and alignment of both encoders. First, we demonstrate the reactive motion synthesis without users' control. The estimated intentions are visualized as orange future trajectories of 5 key joints. Our system is able to produce smooth and high-quality reactions. The motions are rendered in online manner without future knowledge of the input blue character. Next, we compare the performance with codebook matching and motion matching technique. Codebook matching delivers results of reasonable quality at the beginning, but unable to preserve the accuracy of body interactions over time. This decline occurs because the codebook struggles to capture the diverse and dynamic joint relationships between the two characters. It relies heavily on the character's state from the previous step, instead of the interactions for autoregressive synthesis, leading to increasingly inaccurate reactions. In contrast, our approach maps the estimated intentions to potential output poses. The intention feature is transformed into the root space of the reactor, embedding it with the spatial relationships between the two characters. This feature ensures that the generated motions are not only more precise, but also more contextually aware, significantly enhancing the quality and realism of the synthesized reactions. Here, we demonstrate the results on boxing actions. The codebook matching quickly degrades to mean poses or jittery motions, unable to generalize on test dataset. We also test on a dataset featuring ballet dance actions. Our approach produces smooth and responsive motions, while codebook matching collapses and generates low-quality motion. To compare with previous offline method where full motion sequence of input character is provided, we replace the inputs with ground truth intentions for a fair comparison. Our systems still generate high-quality reactions, while ReMOS presents unnatural sudden movement. To demonstrate controllability, we allow the users to control the root trajectories of input character and search for poses within the database, such that we can deviate the character's movement from the original path. Our system remains robust, while codebook matching and motion matching produces unnatural or unresponsive motions. Finally, we conduct ablation studies to evaluate the impact of each proposed module and visualize 10 samples for every step of the prediction process. When using an intention predictor trained in an end-to-end manner, the predictions tend to exhibit slightly more noise. Without the intention predictor, the system struggles to map the observed character states to reasonable output poses. Additionally, removing adversarial training from the framework leads to highly unstable predictions, as the quantized codebook produces more ambiguous outputs for the same input conditions.